All clear? A laptop problem, voice and display. All clear? All three. No laptop problem, display clear, and also voice clear. Why? No comment. Any problem? See? No reply. Display is clear, I can see there. Laptop problem is not there. All clear. Okay. I'll start now. Remember, continuing from yesterday, I already told, if someone today new joined, if things are not clear, you have to blame yourself only. Or attend the class today, up to end, doubt will come. Go back to previous class. That is, heading is what? Footing design part 1, previous class. Once it is fully clear, once again see here. But if right now, if you attend, you will gain a lot. Maybe little doubts will come. But I already told, if you are not going to previous class and want to learn from here, leave the class once for all, disappear from my class. Okay, see. All told now, repeatedly cannot be told. See, this is a column here. See, this is a column. This is a footing. If I place the column here, footing, I have shown clearly, it will bend like this and bend like this. So lengthwise bending will be like this. What you do? The projection of the footing from the face of the column you are taking as a cantilever. So for lengthwise bending, the cantilever span is 0.975 meter either side. And for widthwise bending, see from here, this way bending, the cantilever projection is 0.985 meter. Okay, now, this all I explained now. And remember, this is a case of column subjected to pure axial load. Therefore, upward pressure is uniform. And our uniform pressure is, where is it? Anyway, somewhere I noted down. The uniform pressure is how much? 154.545 kilonewton per meter square. That I told WP. WP means UDL or varying load intensity W. P means pressure acting upwards. So this is the arrangement. This will bend as a cantilever here. This will bend as a cantilever here. Everything told last time. Okay, now write in the procedure sheet. Continue. I will do the problem. Simultaneously will give procedure sheet for you so that everything is clear. See, continue in the procedure sheet. Sketch the plan. Mark the column. Mark footing dimensions. L1, L2, S1, S2. See, this is S1. Remember, this is your S1. This is your S2. In the procedure, should not write 0.55, 0.23. Nothing to be written in the procedure. Okay, then both the sketch you write here, write the design principle, designed for cantilever, designed as a cantilever, fixed at the face of the column and free at the edges. Okay, now start one by one. What is one? I told this is lengthwise steel, this is widthwise steel, that is AST. Okay, leave it. These are already over. First I'll do one thing now. Consider one by one. Lengthwise bending. Consider, don't put the LWB. You will become LBW then. Right? Consider lengthwise bending. One note right there. Lengthwise bending this way. Either side cantilever. Or you can do one thing. Okay. Either side cantilever are there. Both are equal. So, how much bending will come for this cantilever? Same bending for this one. But later, when you write, that I'll give separate procedure for you. But write a note. Later, when we consider axial load with M1 and M2, at that time, pressure will not be uniform. It will be non-uniform. That is, instead of UDL, it will be UVL represented by a trapezium. I will tell you, right? He will tell at that time what to do. And practically, that is more important. Which one? P with the M1, M2. This you never get practically. But then why you require it? If this is clear, then only that will be clear. Okay, start. Consider cantilever. See, lengthwise bending, if I stand in front, one on the left side, one on the right side. Just make a note here. Here you can consider any side. But remember, there, I will give a note for you. There what to do is, you should be careful which side you have to consider. There, one side more bending will come, other side less bending will come. So you consider that side where bending is more. Bending and shear, both are more. How to observe? If the offsets are equal, where loading is more, that side more bending. But some rare cases what happens is, these two offset will not be same because of some problem. Column may be slightly shifted to one side. Then you should not decide based only on the loading. Offset also comes. See, for a cantilever, more length means more bending. More load means more bending. So, sometimes it is possible that one side load is more, but length is lesser. Other side, load is lesser, length is more. In such cases, what you have to do is, you have to consider both sides. Once consider the right side cantilever, once consider left side cantilever. For both of them find the BM, then consider the maximum BM. But here, whether you take the right side cantilever or left side cantilever, both are same. Okay, now, consider lengthwise bending. No. Very important, consider 1 meter strip. These all you know in the slab. Sorry, those who come to this class, they should know about the slab at least something. Not blindly come to the class. They will tell, sir, you in the class, you have not done slab in YouTube. You study. This is extra I am giving. So consider 1 meter strip. Now see, where is that 1 meter strip? I will show it for you, just to understand. See here now. This, I will write here, see. This is the plan. I will rub this one after everything is clear. This is a plan. This is your column. Consider 1 meter strip. See, when bending is this way, see this way bending, or now see, we are taking both as cantilever. I will put sketch once again here. See, one cantilever here, one cantilever here. It has got upward load here, it has got upward load here. Both are equal, WP equal to, where is it? 154.545. 154.545 kilonewton per meter square. Now, this you are supposed to know in the slab. I told so clearly in the slab. What? Even though load is kilonewton per meter square, when you take 1 meter strip, that meter square is cancelled, it becomes what? I told you in the slab, not once, 100 times I told you. See, now, when you take 1 meter strip, it is, see, this is the projection. You take 1 meter strip near the column, this way. This is your 1 meter strip. Same strip will be there here also. Actually, should not take here because here bending is lesser. Where column is pressing, that is the place where more bending. So this is the 1 meter strip you are taking. So this is your 1 meter strip. In the plan you can see it. Here it is like this. And one more thing, this projection is how much? 0.975 meter. You do one thing. Those who write theory, you write this is projection lengthwise, PL. Projection lengthwise. You write projection lengthwise. Okay. Now, this I told you very earlier. Even though we write load 154.545 kilonewton per meter square, the moment you take 1 meter strip, this 154.545 kilonewton per meter square will suddenly change over to what? Tell me. Will suddenly change over to what? Fast. That kilonewton per meter square will suddenly change over to. When you consider length along the span, that kilonewton per meter square will become fast. In the slab I told you. In the slab, not once, 100 times told. Kilonewton per meter. Remember, this is, I told you, it is for 1 meter length, width 1 meter, 154.545. Okay, now continue. Calculate maximum bending moment. Maximum bending moment. Okay, now maximum BM will be for a cantilever. See here, it will be always here, because I told you this will bend like this, this will bend like this. So tension comes to the bottom. All told earlier, at the face of the column. At the face of the column. And remember, even IS code also told you critical section for bending moment should be through face of the column. Okay, equal to, you can write formula if you want. WP is the intensity of load into the projection PL. L means not left right. L is not left right. L means lengthwise, or PLW. PLW into PLW is the total load. WP into PLW total load into the distance. How much? Into PLW by 2. This is for lengthwise bending. Remember, later when I consider widthwise bending, my cantilever will be this way. At that time, no change. Instead of P lengthwise, I will write P widthwise. Okay, now, by chance these are unequal, you write P lengthwise on left side or P lengthwise on right side. Okay, start. Equal to 154.545 into where is it? 975 is the total load into 0.975 by 2 is the maximum BM for lengthwise bending. It will come in kilonewton meter. Answer fast. Answer. Don't give wrong answer. Give correct answer. Give correct answer. I do not want wrong value. Remember, if you give a wrong value and after some time, if a correction comes because of the wrong value from you, suddenly I stop the class. I will tell footing remaining part I am not doing. That's why at least minimum 2 answers should come. You don't see, if you make a technical mistake, I never bother. You always make, I will see that you make the mistake. So for that I am there to correct it. But in such places, if you make a mistake and that later, sorry sir, it was wrong, means I will stop the class. That's stop the class and stop this chapter for ETAB and save. RCC batch also same applicable. Others helpless, what to do? Your bonus gift stops there. That is, during the meals, halfway through till meal over. 73.46, okay. Someone told 73.46, only one person told, others later. If answer is wrong, everybody will pay penalty. I will stop the class. I will stop the class immediately. Remember, immediately stop the class. I will not listen to any word. See, after telling this much, only one person gave answer. Others are enjoying. Later, see sometime calculation mistake happens due to wrong pressing of button. Then later, you will be responsible. Outrightly, without mercy, I will stop the class. Okay. This much time is sufficient. Now if it is wrong, class will be stopped. Now, okay. Class will be stopped. Okay. Kilonewton meter. Okay, now make a note now itself. I will not repeat once again. Later we want, see, maximum BM here at the face of support or where fixed end is there. Anybody can tell where is the maximum shear force for cantilever? Answer. Maximum BM is at the fixed end. Where is the maximum shear force? First. That's the reason for this one. Later I will tell, already explained. You should make a note. Where is the maximum shear force? That also at the fixed end. Now, suppose you want maximum bending moment, what? Intensity into length will give total load into bending moment means what? load into distance. See, sagging BM. Sagging. You write here. This is sagging BM. Okay. Now, suppose I consider a section somewhere here. This side. Tell. Or if I want shear force here. Bending moment means load into distance. Shear force means only load. So, maximum shear force will be 154.545 into 0.975. That's all. This into is not there. Clear? For shear force, only load. 154.545 into 0.975. Clear? Clear or not? Fast, fast. Comment should be given fast. For some reason I am telling. Clear? But remember, make a note. Maximum bending moment as per IS code, they told you should consider at the face of the column. But later, when you check for shear, two types of shears are coming. See, the footing design is one of the most important in a building. You should be very careful. Everything I tell you should write. When there are two types of shear, one is two-way shear, all-round shear, or called punching shear, not punching shear. PU, punching shear. That is special. I will explain. Other shear is your usual shear. You can remember usual shear or shear which will create diagonal tension or one-way shear. But at that time, you need not see, if I consider here, shear force will come 154.545 into 0.975. I will make a note. I will make a note here. See, also maximum shear force, that also at face of column equal to 154.545 into 0.975. Tell the answer. It will come only in kilonewton. Just make a note. Later I will not explain. I will tell, go back, told earlier, study 100 times. Answer. Answer. This lag problem I should remove earliest possible, because once in a while I ask answer. 150.68. Okay. 150.68. You write here and round off and put a question mark. Reason, right here. This is the maximum shear force, correct. So, our footing slab should be able to resist a BM of 73.46 and shear force of 150.68 kilonewton. But, right there, full right here, full page, ಆದರೆ but, if you consider same shear force, it will be 100% highly unsafe. This is disastrous shear force. Then what to do? Leave it? How you can leave it? No. Because this is not punching shear right here. All this discussion is for the shear later. Our usual shear, I will tell you. That is the best to remember. Our usual shear or one-way shear. Punching shear is separate. Okay. A punching shear, I am removing the full board and explaining punching shear. Don't worry. Later I will tell you that old cantilever, that loading because of the bending moment shear force, that shear force critical. But remember, because of that shear, if diagonal tension comes, it will come at around 45 degrees this way. 45 degrees. Therefore, when the column presses there, if the column gives compression, then I should not tell further, because then I will be answering a puzzling question I asked in RCC. Okay, briefly. Because the column is in compression, they told if the supporting member is compression, then it will close the diagonal tension gap. Therefore, IS code told you need not consider shear force of 150.68. No, they told not required, because of course very severe. You need not design for that shear force. You can design for a lesser shear force. Someone will tell, how possible? Yes, IS code told. So later for shear force for critical section, they told from the face of the column, you move by a distance equal to, how much tell me? Critical section for one-way shear or usual shear. Punching shear is separate. You move by how much distance, if you know it? You consider critical section not at the face of the column. They told that much danger not required. You can go a little inside, which will give you lesser shear force. Design for that one sufficient. Tell how much, tell me? Not D by 2, sorry. D by 2 is for punching shear. I have not told it. Sorry, you forgot. I told in the RCC class. You are not, you came long back for RCC class. Actually, how much RCC I did for that batch, from then onwards, for not a single batch, that much I did. It is not D by 2, sorry. See, these things should come to your mind. This is not by-hearted. When this angle is 45 degrees, IS 45 degree angle, punching shear is separate. It is at a distance of D. D. We don't know D. Therefore, later I will put this sketch. Then I will tell IS code told critical section for shear, consider at D from here. So now just write, just imagine, time being, you write note. Suppose D is 0.5 meter. Just make a note, wrong, to understand. Later something else will come. Round off. Suppose D is 0.5 meter. Tell me what is this length first. If D is 0.5 meter, tell me that length first. If D is 0.5 meter, then that side length. Shall I come up to 1 year? If D is by chance 0.5 meter, by chance, if it is 0.5 meter, later it is not 0.5. We will be knowing D value. That will be 0.475. This will be 0.475. Remember, round off. Then as per IS code, shear force to be considered at critical section equal to how much? Look that side. 154.545 into 0.975 into how much, tell me? Into 0.975 into how much, tell me? Shear force to be considered. Into how much? Into 0.975 into how much? I want into 0.475. 0.475. It will come. How much will come? I don't know. How much? Okay. It will come 73.41. Remember, just explanation, 73.41 kilonewton. Okay. Make a note. So, if you want to maximum, this is all imagination. Later, the correct value will come. Just a note. Maximum BM you consider here. Where is the sketch? See, here. Total W into length by 2. Shear force here will come W into L. No, you take shear force here. Look that side. 154.545 into whatever your projection minus D, that is the shear force. Tell me, same thing here also later. For maximum BM, consider here. For maximum shear force, move by D. Tell me, fully clear? Later I will not explain. This will come in the end of the class, maybe after 8 o'clock. Or this may not come today also, who knows? Because so many things I have to explain for you. This may not come today also. Even if it's not coming today, if it comes next year also, you should remember. Clear? Even if it comes next year also, you should remember. Now, when I go there, I will not tell once again. You should tell clear. If clear, I will continue. You should just tell clear. It may come today or may not come today. Because why? So many things are there to consider. But still, when it comes, you should be ready for it. Clear? Okay, done. Now, immediately write. Consider, now remember now, lengthwise bending, see, for this lengthwise bending, This bending, the bending moment comes this way, it is sagging BM. How much you got answer? Length, I write somewhere here, I will forget later. Okay, lengthwise bending, maximum BM, we got 73.46 kilonewton meter for 1 meter strip. Very important. Start. Now, start. Consider widthwise bending. Widthwise bending. Once again, consider 1 meter strip. I will show you where is 1 meter strip. See, widthwise bending is like this. So, your strip will come like this here. See, this is your 1 meter strip. And now, when you consider cantilever, okay, I will do one thing. This I will, here I can do. Okay, do one thing. See here. One cantilever this side, one cantilever this side, I can remove. Both the cantilever, the projections are how much? 0.985, 0.985. You can take it as projection widthwise. Pressure is same. How much? 154.545. See, these all you are going for learning purpose. Later all these your E-taps and safe will do. You don't have to do. But understand correctly, important. Okay, start. Once again find maximum BM at the face of the column here. WP into widthwise projection into widthwise projection by 2, or if you calculate, it will come 154.545 into 0.985, close the bracket, into 0.985 by 2 will give you maximum BM for widthwise bending. Answer. Don't give wrong answer. Now onwards I will do one thing. Any sorry you tell later. See, if you give a wrong answer because of my trapping, okay, then I will take the calculator. If you give a wrong answer because of calculation and after some time tell it is wrong, I am going to end the class immediately. Stop. Just because today it is very hot also. I will be so happy. I will switch on both the fans. I will take a cold water bath and enjoy. That's all. So at least 2% should give the answer. If it is a trapped answer, no problem. I know it is wrong. Why? Because this is going to live in YouTube permanently now. Tomorrow I do not want someone to comment. If somebody comments, I know how to take care. But I cannot keep on answering those people in the comment box. I never answer in the comment box. See the comment box? I never answer anything. Not required. I never answer. Someone asked a question recently. What is internal force? I kept quiet. This is not a core, that YouTube class. YouTube class, I don't discuss that. I have better work to do. What I teach, you understand. What food I give, enjoy. Don't ask for details. Where you got rice from where you got butter, or from where you got this one. You eat if you want, or keep quiet. 75 ಆಯ್ತಾ ನೋಡಿ, ಯಾರೊಬ್ರು 74.97 ಅಂದರು, ಇನ್ನೊಬ್ರು 75 ಅಂದರು. ಎಷ್ಟು ಬಂತೋ ಅಷ್ಟು ಹೇಳಿ, ರೌಂಡ್ ಆಫ್ ಮಾಡಬೇಡಿ. ಡು ನಾಟ್ ರೌಂಡ್ ಆಫ್. ರೌಂಡಿಂಗ್ ಆಫ್ ಐ ವಿಲ್ ಡೂ. ರೌಂಡಿಂಗ್ ಆಫ್ ಐ ಆಮ್ ಡೂಯಿಂಗ್. ಯು ಟೆಲ್ ದ ಆ್ಯಕ್ಚುಯಲ್ ಆನ್ಸರ್. ನೋಡಿ, ಅಲ್ಲೂ ಡೌಟ್ ನನಗೀಗ. 74.97ಗೆ ಯಾರು 75 ಅಂದರು. ರೌಂಡ್ ಆಫ್ ನಾನು ಮಾಡ್ತೀನಿ. ಎಷ್ಟು? 74.97. ಇಟ್ ವಿಲ್ ಕಮ್. ಎಲ್ಲಿದೆ ಅದು? ಇಲ್ಲಿ ಬಿಡ್ತೀನಿ. ಅದಲ್ಲ. 74.97 kilonewton meter is the maximum bending moment for widthwise bending. Remember, this is again for 1 meter strip over. So, I will remove this sketch now. Anything required? 1 minute? No, nothing required. Just a minute. Okay, not required. Nothing required now. I will give a note here now. See. Therefore, see, for lengthwise bending, maximum BM equal to how much? Oh, forgot. I not seen it. Okay, I can see comment box. No problem. I can see comment box. ಎಲ್ಲಿದೆ 73.41 1 minute. Tell what is the lengthwise projection. Tell what is the lengthwise projection. Tell me. What is lengthwise projection? First tell me once again. I forgot now. What is lengthwise projection? Lengthwise projection. I forgot it. No. Lengthwise projection. .975. Widthwise is 0.985. So slight difference. So for lengthwise bending, maximum BM equal to, what is the answer? Studied you? How much you told earlier? Nisha? No. What is the maximum BM for lengthwise bending you told earlier? 73.46. 73 point. See, I am taking class very, very slowly. Kilonewton meter. And for, I'll write here. And for widthwise bending, maximum BM equal to, just now you got 74.97 kilonewton meter. Tell me, why these two bending moment came almost same? Tell the reason. Why this bending moment came almost same? Reason. Why this bending moment came almost same? Slight difference, okay. Almost same. Reason. Why this bending moment came almost same? Because we maintain same projection. Suppose now the critical bending moment is 74.97. We will find the depth for this bending moment. Now, by chance, you listen to the special person. I don't want to name the book person. He told projections you provide in proportional to column side. Then, do you know what BM will come? One of them will come 120, other will come 30. Means what? Highly uneconomical. Their footing will come this way then. One side footing will be this way. Widthwise footing will be this way. This is a very huge bending, small bending, fully wasted, highly uneconomical, dangerous shear. Everything is dangerous there. Actually remember, nobody is doing that way. Everybody in the world who knows subject, people usually I have seen, very few people tell you, provide the footing dimension in proportion to column side. Those who are in the right mind, everywhere you go and see, they will tell equate the projections. Okay, leave it. Now I should not bother about other people. Now, okay, see, very, very important. Now what I am telling. Start. Now, in the theory, right, we got maximum BM. Based on maximum BM, you find what is the depth required. Structural depth. When bending is this way, the thickness of slab is structural depth. Clear? When bending of slab is like this, see, when you do pressure calculation for bending moment, then structural depth and width are planned dimensions. But when you consider bending moment shear force for the footing slab, structural depth is thickness of slab. Clear or not? Structural depth is thickness of slab. Clear? The structural depth is thickness of slab. Clear or not? For the slab bending, for bending of the slab and shearing for the slab, structural depth is thickness of slab. You are not any clear fast. The pressure calculation, it is something else. Okay, clear. And remember, structural width, how much? These are the bending moment, both of them for 1 meter strip. Remember, therefore, B equal to 1 meter or 1000 millimeter. And remember, capital D, structural. These both are structural. Your structural D is thickness of the slab. Thickness, okay. Thickness of footing slab. Footing slab. Now remember. Okay, start. Now, right, next step. Now we have to find the thickness of the slab. Remember, make a note. Thickness of slab is for a footing slab, your thickness provided will be always based on what? Bending or shear? Tell me. The thickness provided is always based on bending or shear. Answer. Usually for RCC floor slab based on deflection and bending moment. Their shear is very what? For floor slabs all, shear is very ineffective. It is negligible. We don't consider it. But for footing slab, remember, slab thickness is to be finalized based on bending or shear. But bending or shear first. Slab thickness to be finalized based on bending or shear. You are not giving. Clear is old clear. I am asking bending or shear. This I told you. For floor foundation slab, it is always based on shear. Now, one problem. If you want to fix based on shear, two types of shears are there. All of this you write there in the theory. One is punching shear, other is wide beam shear. To know both of them, you should know critical section. Critical section is at D/2 from face of the column for punching shear, whereas D from face of the column for our usual shear or wide beam shear or one-way shear. Now, we do not know D. So what we do is, first we will find right here. First we will find what is the thickness required based on bending moment. What is the thickness required based on bending moment? But we know that thickness required based on bending moment is not sufficient for shear. 100%. It will be unsafe in shear. My guarantee. Therefore, you first find the thickness of slab depth based on bending moment, then provide higher value or lesser value. Tell the answer. Provide higher value or lesser value. Provide a little higher value or lesser value. I am shouting non-stop. Critically shear. Provide higher value. Increase by some percentage. Usually people give double. That is 100% more. But sometimes 75% more will be sufficient. Or rare cases, even 50% more may also be sufficient. So tell what we will do. We will go for economical design. We do not want to waste. 50% is highly dangerous. If you give 50% more, 95% chance that it will be unsafe. If you give 75% more, it will be almost okay. Whereas if you give double, it becomes safe. So what you can do? When you do practically, people go for almost double. But in my class, I want economical design. I will go for 75% more. Sometimes we get safe. If unsafe comes, some adjustments are there. Okay, don't worry. I can take 75% more. Then see what happens. Okay. Now, further. D is the bending moment over. Start. What to do? You see, mu is the bending moment. Bending moment to be resisted. To be resisted. What is mu limit? Tell me. What is mu limit? Remember, you require RCC now. Mu limit is what? Mu limit is the BM that can be resisted by singly reinforced, I should not write first of all, singly reinforced rectangular balance section. For ETAB batch and RCC class, this is told already more than 100, 200 times. Other people, they should know it. If you ask me, sir, please explain this one. Sorry. My class is for design of footing. For this purpose, RCC part I cannot take. You are supposed to know it. I will tell, if you do not do those things, then you better not design footing slab. You are not fit for design. I will tell that way. Little harsh statement only. So what you do is equate mu to mu limit and get small d required and then capital D required based on bending moment. Okay, start. Now first formula, mu limit equal to, I should not tell for this class, sorry, I am wasting my time explaining mu limit. 0.36 into xu max by d into bracket 1 minus 0.42 xu max by d into bd square into fck. If anybody comments like 0.133 fck bd square all, I will tell get out of the class. I never believe in those crude methods. Remember, in numbers, I stick to basic concept. That's all wrong concept. People telling mu limit, they write formula. For M15, M20, tar steel, they write 0.138 fck bd square. For Fe500, they write 0.133, I think. For mild steel, I think 0.14 something. And sometimes M20 concrete and FP415, they put 2.76. That is the number we get. No, my class, such things will not work out. It is always basic. So start. Now, we are using which concrete I told you? I forgot. Tell me, which concrete I told you? Forgot now. Which concrete I told you? Which is the concrete I told you? I forgot. In the question, I have given which concrete? M25. Okay. We are taking M25 concrete for which FCK is 25 Newton per mm square. And Fe500 steel, we got Fy equal to 500 Newton per mm square. And also, anybody can tell me what is xu max by d? How much? Answer first. Xu max by d. If someone comments what is xu max by d, I will tell high time, leave my class. You go to directly design of 100-story buildings. You leave my class. You are knowing too much. You start designing. Now tomorrow only take a project. 100-story building. How much? 0.46. Thank you. See, when someone gives the answer, others should know, oh, this is RCC part, we are supposed to know. Okay. Now start. Now, equate mu to mu limit. And remember, 1 meter, mu limit. Which mu means, which one? Tell me. There are 2 BMs are there. Tell among the 2 BMs to fix the depth, which mu you have to equate? Higher mu or lesser mu? Which one? Tell me. Higher or lesser? You should consider higher BM or lesser BM. 2 bending moments are there. When you want to decide the depth requirement, which one you have to take? Higher value. So mu means higher. And 10 to the power 6, how much? 74.97. 10 to the, right here, see. 74.97 into 10 to the power 6. Why? Because we want in Newton millimeter equal to 0.36 into xu max by d into 1 minus 0.42 into xu max by d into b is 1000. I told you, when you take 1 meter strip, width is 1000 into what? Into d square into fck is 25. Therefore, you get the value of effective depth d required for the slab. Answer first. First give the answer. First. Sometimes you take lot of time. Divided by 1000. divided by 25 equal to root answer. Fast answer. This much difficulty to get D required. If this much time you take, I cannot take the class. If you take this much time to take the class, one 149.82 millimeter. Tell correct or not? I want tell correct or not. I calculated. 149.81 ಅಲ್ಲ 149 ಪಾಯಿಂಟ್ ಅಲ್ಲೂ ಚೌಕಾಸಿ ನೋಡಿ 149.82 ಅಲ್ಲೂ ಚೌಕಾಸಿ 816 ಇದೆ ಅಲ್ಲಿ 82 millimeter. Tell me correct or not, fast tell me. I want comment because I want to go to next step. Correct means I will go to next step, otherwise later class I will stop. You calculate, divide, D square will come, take root. No, I want is this number correct or not. Why type once again? Just at least someone should comment yes correct, then I will go further. Just comment correct, I will go further. See, correct, okay. Now next step. Now tell me, up to here everything clear? Up to here everything clear means one important point. Up to here everything clear? Up to here everything clear? Clear or not? Up to here you are not answering. Yes. Now see, I took the calculator. Why I took the calculator? Those who are in the RCC batch, here one problem is there in YouTube. I will not be knowing who is participating. I will know only number, how many are live. And those who give comment, I can make out the name. Other names, there are so many are there. There are around 9 people are there now. Except some few people who are giving comment. Others, I don't know who they are. In Zoom, I know each and everybody who is present. Very sorry. Those who came to my RCC class, I should block them now. You already told earlier. ನೀವು ಕನ್ನಡದಲ್ಲಿ ಪ್ರತಿಜ್ಞೆ ಮಾಡಿದ್ದೀರಾ ಈ ತಪ್ಪನ್ನ ಇನ್ನೊಂದು ಬಾರಿ ಮಾಡೋದಿಲ್ಲ ಅಂತ. Repeatedly made mistake, I corrected, then you told this mistake we will not do once again, and again you committed the mistake. And those who are in the ETAP batch, for you also same, but RCC people harsh. Why? They are basic RCC. ETAP people little lesser RCC. Why? Only I am telling RCC structural part. Not in detail, like for them I took more than around 200 hours. For them I took around 200 hours. For you, see lesser. What I told earlier, remember? What I told? If you still make the mistake, no, now will not do. Someone, I know the answer. I noted down here. 183.5 millimeter. I got it. I took the calculator. I got 183 point something. Then I made your mistake. I got this number. What I told, there is no excuse this time. I told 1000 times. Lengthwise bending 73.46. Width, I have left a space here. See, I have left a space here. I have left some space here also. These values are for, tell me, that upward pressure we got, it is for working load or factored load. Tell the answer. The upward pressure, 154.545. Is it due to working load or factored load? No. Is that 154.545 kN per meter square? It is for working load. So whatever BM or shear force you are getting is corresponding to working load. This is for working load. I don't know what, if it is an offline class, what I will do? I will again make fun. I will tell, what is this? Okay, now, therefore, without forgetting, I told important, taking gamma f equal to 1.5, factored bending moments are, see, you see here, mu is what? Mu is fact. I have not written earlier because if I write earlier, someone would have tell, sir, 1.5 required. Trying to trap only. This is, mu is what? Is maximum factored BM. Okay. Therefore, factored BMs are what? How much? 73.46 into 1.5 equal to, what is the answer? 73.46 into 1.5. What is the answer? See, what I can tell now, if you still make the mistake, I don't know how to correct it. If you go to practical field, if such mistakes are done, what will happen? Imagine, what will happen? If such mistake you do in practical design, who will come to your rescue? 110.19 kN meter for lengthwise bending and, you know this, 74.97 into 1.5 equal to how much? 74.97 into 1.5. How much? 74.97 into 1.5. 112.46. 112.46 kilonewton meter for widthwise bending. Therefore, tell me, this is utterly wrong. Tell me, what value you have substitute here? Anyway, mistake is what purposely made. Someone who is going to my YouTube class, imagine he knows subject, or he is going to my class for checking my capacity. He will be so happy now. Got him today. He considered working load pressure and he took that as mu. He will be very happy, but now he will be fully disappointed. I thought I got him. But finally, no ball. Today, see, in the World Cup match, India is supposed to win. They would have won the match. The penultimate ball, they pulled a no ball, and because of that, they lost the match. They could not qualify for the semi-finals. I thought they will win. Just lost some 3 runs required. So therefore, but at that time, the ball bowled 1 run they took, but it was a no ball. Okay, what to do? Then the person will be told, I thought I got him. He's out declared. Later, third umpire told, not out. How much? Now it is not 142 point. How much you are substitute here? How much? Higher value. 112.46, 10 to the power 6. Tell the D required. Now tell the D required. Never make this mistake in future. You agreed earlier, not once. So many times you agreed. Still I don't know why you made the mistake. Now tell D required. That I already got here. I wrote it down here. What is D required now? Now you get correct answer. D required. What? Someone told earlier. I have the comment box. You can tell now. I got 183.17 adu. Sari kanta illa. Partially rubbed out here. I wrote in the bench. What is D required now? First. You are not telling answer no. 183.49. Okay. 183.49 millimeter. Now tell me, at least in future, will you be careful or not? In future, this mistake you should not make. Agreed? In future, this mistake you should not make. Every time same thing. In future, this mistake you should not make. Agreed or not? Agreed. No problem. It is exactly like my story when I was, no I am not, when I was going to primary school etc. I used to be very what troublemaker. I used to get lot of beating in the house. After that one, my father will tell. Lastly, he will tell, ಕನ್ನಡದಲ್ಲಿ ಇನ್ನು ಮಾಡ್ತೀಯಾ? ಇಲ್ಲ, ಇನ್ನು ಮಾಡೋದಿಲ್ಲ, ತಪ್ಪು. I will tell every time, in future, I will not make the mistake. And he knows that I will make the mistake. I also was knowing that mistake will be made. Okay, that is lighter side. I always will tell, ಇನ್ನು ಮಾಡೋದಿಲ್ಲ, because ಏಟ್ ಬೀಳ್ತಾ ಇದೆ ಅಲ್ಲಿ, ಇನ್ನು ಮಾಡೋದಿಲ್ಲ. See, so structure, see, here there is no excuse. If such mistakes are made, there is no excuse for you. You cannot tell, I forgot load factor, I decide for working load by limit state method. Sorry, no sorry will work out. Over. See, now all I will remove 183.49. Now, one important concept is there. This is only for practical design. Remember, only for practical design. See, if I take a section this way, no, see, if with a footing slab here, make a note. Little bigger I'll write so that it will be clear. Make this note. If this is the footing slab, see, this is only for practical design. Academically you can write, no problem, but people want different. See, if lengthwise bending, if the steel comes this way, see, I am showing diameter. This is the steel for lengthwise bending. This is what? One bending. See, suppose imagine this is steel in one direction. In, I don't know. It may be other way also. It can be, so some people may put it other way also. Steel in one direction. This is steel for other direction. Correct? This is steel in perpendicular direction. Because one side you need steel this way, one side you need steel this way. They are placed like this. Now, if you place lengthwise steel first, then widthwise steel, sketch will be like this. Suppose you place widthwise steel first, then lengthwise steel, then sketch will become ulta. This will come down. Clear or not clear? Or it can come this way also. See, if you take other way section, this is one steel, this is other steel. Clear or not clear? Like a two-way slab. Yes, okay. Now, practically what happens is, when you give detailing, you are not going to tell them, you place, see, this steel first, this steel next. That you have to tell when you have got abnormal projection or when one projection is too high compared to other. For this equal projection type, they will simply give drawing like this. Sorry. They will give drawing like this way. 10 tor at so and so, they will tell 10 tor at so and so. They will not specify which one first, which one next, because when you consider the depth of around 400, 500, 600 like that, the small mm does not matter. Now, therefore, for one of the steel, this is D. This is D. For other one, this is D. Correct? This is the D for what? So if I take this steel from center here, this is D. Remember, this is clear cover. Clear cover. Other one, this is D. Both are clear. One, that like two-way slab, D will change in two directions. Clear or not? D will change in two directions. Okay. Now, if you decide now itself which steel you are placing this way, which steel you are placing this way, then problem comes. Same problem comes in safe also. Therefore, what people do is, they will consider to be safer side, 2D values are coming. To be on the safer side, for both the bending, you consider a common D. Which one? Tell me. Higher D or lesser D? Tell me. To be on the safer side, write note. To be on the safer side, you don't worry which steel is placed first. That all you don't bother. For practical design, you take whichever steel has got higher D or lesser D. Tell me. Which D? Lesser D. Because, see, suppose this D is 500, this D is 490. Then, by chance they put the other way steel, it will become problem then. So do one thing. Even this D is 490. This D is 500. Even though 500, you tell it, hey, you are also 490. It will tell, one will tell, I have 490 rupees. Other will tell, I have 500 rupees. No, okay. You have 500 rupees. Okay, you imagine you have 490 rupees. Why? Both of them I will take equal. So right here. Therefore, no, not therefore, D required over. Consider, diameter of bar. After this one, next step actually, see, or here, next step. This all statement you write there. All the statement you write, then write. We got D required equal to 183.49 millimeter. Okay, now, taking clear cover. Anybody can tell me, for foundation reinforcement, what is the minimum clear cover? First, it is not 20 mm or 30 mm or 40 mm. For foundation, minimum clear cover. How much? 50 mm. Clear cover of 50 mm and considering 1 minute. I told you 1,000 times in RCC class and ETAP class. Those who are newcomers, believe me, that's all. Suppose initially better to consider higher diameter or lesser diameter. Tell me. Initially, it is always better to consider higher diameter or lesser diameter. You tell the answer. Newcomers will believe you. Initially better to consider what diameter? Little. Higher side or lesser side? Higher side. So usually for this type of foundation, they prefer 10 mm bar or 12 mm bar, or worst come worst, they will go for 16 mm bar. So I will take considering what? 16 tor, 16 to be safer side for such footing. But remember, if it is a heavy building where load is around what? If the depth comes around 700 like that, then means later when you increase, it may become more than 1 meter. Then you go 25 tor. Okay, now for normal case and considering 16 tor, consider 16 tor. Take clear cover 50 mm and consider 16 tor. And consider D constant for both bending, not ending, both bending. Make a note. Someone will comment. How you can take more? Keep quiet, I told already. One has got 490 rupees, other has got 500 rupees. I will imagine he also got 490 rupees. Considering for bending, that is least D. Least D, that is to upper layer of bars. Upper layer of bars. Tell the value, what is the capital D required? Capital D required equal to full depth, small d required plus 50 mm clear cover plus 1 full diameter plus again diameter by 2. This should be clear for you. See, this is the bar in one direction. This is a bar in other direction. You take this D. This D you take how much? Requirement. 183.49 requirement. This is the capital D. So 183.49 plus 50 clear cover plus 12 mm diameter plus half of 12. Answer. Answer first. This should be clear. Answer. Small d required plus clear cover 50 plus 1 full diameter plus half diameter. You get the capital D required. That is safer side, common for both. Actually, some will tell, for the two bendings, D slightly varies. You tell them, I know it varies, but I am taking whichever is lesser, therefore safer side. Okay, see, answer. This much time to give an answer. Adding 183.49 plus 50 plus 12 plus 12 by 2. 183.49. 251.49 millimeter. 251.49 millimeter is the capital D required. Now, this is based on what? Tell me. Based on what? This is based on bending moment or shear force. This is based on bending moment or shear force. Very important. This is based on which one? Bending moment or shear force? Based on bending moment. BM. Now write a note here. What note? Write a note here. You write note. In case of, I am dictating here, you write it. You write it here. In case of footing slab, the depth if you provide based on bending, I am so sure it is going to be 100% unsafe. It is not sufficient because for footing, shear is very, very critical. Therefore, accounting for high predominant shearing effect, predominant shear, which shear? Two types of shears are there. Both of them are equally troublemakers. Remember, punching shear and our one-way shear, both are equally destructive. Therefore, accounting for predominant shear, let us increase capital D by approximately, remember, 50% is not sufficient. Danger. Double is not required. So many people, economical design, how much? We will do one thing. We will go economical. If unsafe, we will redesign. No problem. I get the break then. How much percent? Tell me. If you increase by 50%, it is danger case. If you increase by, if you take it twice, it is surely safe, more poorly safe. But 75% is economical. How much you decided? I told already. What percent will increase? Fast. What percent? I already told the answer for you. In the class, what you will take? 75% by 75%. Remember, it is your choice. One make a note. In E-tab and safe model, this trouble is not there because based on judgment, provide thickness of slab. Unsafe means go to property, change the thickness, run over. These all you don't do in safe. In safe, you do nothing. You prepare the model, run, it will give result. So therefore, that is capital D, try capital D, approximately how much? 251.49 into 1.75. Answer. 75% more means 1.75. Answer. 251.49 into 1.75. 75% more means multiply by 1.75. Don't multiply by 0.75. How much answer? Multiply by 1.75. You get the capital D required. This much difficulty to capital D. One multiplying number, 440.10. 440.10. Therefore, I will do one thing now. See, I will try. Okay, here I will try. Space problem is there. I want to remove everything. I will try, or I will write here only. See, try capital D. Round off and tell the answer to me. 440.1. Little liberal. Round off. 440.1. Round off. Little liberal. 500. You are going too much more. No. That much I don't want. If it comes unsafe, I want it to come unsafe. 450. I will try capital D of 450 millimeter. Okay, now make a note. Once you get the capital D, therefore calculate what is the D, actual D provided. What is the actual D provided? Provided means the lesser value. How much? Now remember, provided you want. When you want small d to capital D, You added cover and added. Now you have to subtract. So it will be equal to 450 overall depth minus clear cover 50 minus 16 minus 16 by 2. If this is not clear, high time, better leave RCC. If you know small d, if you want to capital D, you keep on adding cover one full dia and half dia. Whereas if you once you decide capital D, if you want to find what is the real small d, from the capital D, subtract cover, subtract dia and subtract half the dia. Answer. Actual D provided. 382 millimeter over 382 millimeter. Okay, now one note you have to write. See, you have to write one note now. Very important note. Now we decided the slab thickness. That is, we finalized it as 450 millimeter, for which D is one direction. Actually, D is little more, but no, we will actually. In other direction, one more D will be little more. But in 5 and 450 mm, this 12 mm more it will be. We will not consider it. Why? Safer side. So even though D changes, we consider same D for both the steel. One of them is slightly more safe. This is to take care that let them place the steel whatever way they want. You are safe. Why? This much D guarantee there. Even if they misplace. If you want to place like this, but if they place like this also, this D is guaranteed, yes or no? This D is guaranteed, yes or no? See, this D is guaranteed. Huh? Then who told 382? Who told 382 then? See, now same person is telling 376. See, where is 12 mm? I took 16 mm. See, you are imagining things. I took 16 mm bar. Where I took 12 mm bar? I took 300 and you never imagine in my class. Who told 12 mm? I took 16 mm, correct? Oh, sorry. Oh, there's a misprint is there. See, sorry, go back. It is not 12. Correct it. 16 plus 16 by 2. Oh, yo, forgotten. Tell the answer now. Change. Correction. I wrote 16 there, then forgot it. Change the answer. This D. This is not clear. I told 16, by mistake took 12, because I know later, I know that 12 only is coming. Okay, change it, no problem. So answer. Change the answer. How much? First answer. Change it here. From here, change it. Capital D, you should have told me at that time. See, your mistake. I told take 16 tor. When I consider 12, you should have commented immediately, not 12, 16. See, for me, I forget, because I know finally it is going to be 12 mm only. But I told you safer side take 16. By mistake, I took 12. That means you are not interested. You are not correctly understanding. If you are understanding correctly, you should have told not 16, not 12, 16. Your mistake. See, that is called involvement. You should tell, if I make a print mistake, you should correct it. This is called a print mistake. How much? 250. You are not telling that number only. 183.49 plus 50 plus 16 plus 8. Calculator is not on. 257.49, correct? See, this is called unnecessary time waste. You should have told me earlier. So it is 257.49 into 1.5. How much? 257.49 into 1.75. See, 1.75. 450.6 millimeter. That is almost equal to 450 only, no problem. Why? Because imagine not 75%, 74.5%. Okay, that's okay. Okay. Therefore, we will try 450. D equal to how much? D equal to 450 minus 50 minus 16 minus 16 by 2. What is the answer? 450, see, 450 minus 50 minus 16 minus 16 by 2. See, I 376 millimeter. See, I will put the blame on you only. See, you are only responsible for this delay. When I wrote 16 tor, when I wrote 12, you should tell me it is not technical mistake, it is a print mistake. I was under the impression 12 tor. That means you are not serious. See, this also is a reason to stop the class. Remember, I can stop the class for this also. Telling that I wrote 16 there. When I wrote 12 here, why you did not tell 16? See, if you are serious and interested, you should tell that one. Otherwise, there are people who will laugh. He wrote 16 there, later took 12. Does not know number system. Let them laugh, no problem. Okay. Now, see, around 10 minutes time wastage, you are only responsible. See, it happens sometimes. See, what happens is, when you feel tired or non-stop talking, in the mind I know that 16 tor is not required. I know for this most probably 12 tor or 10 tor or who knows, maybe 8 tor also. So, or 10 tor. I know 16 tor not required. So suddenly to my mind, I thought 12 taken. You should have told me at that time. Okay, 376. Now, make a note. These things actually will unnecessarily, time is wasted in the class. Such wastage you should eliminate by correctly participating. Okay. Now, make a note. First note, non-stop talking for more than 1.5 hours, he will take a small break. You don't waste now. Then, second note. Now we got the depth. When you provide this depth, we first considered bending and got the effective depth for that one. In one direction, D is more, other direction, D is little lesser. For safer side, for both of them, we took smaller D. So we will take D 376. Someone will tell, other way 12 more is there. Keep quiet, I will tell him. Okay, then. Now, there is no guarantee that the slab thickness is sufficient, say pin shear. Which shear? Either punching shear or wide beam shear or one-way shear. Punching shear is called two-way shear, all-round shear. See, punching shear is all-round shear. And one-way shear is our usual shear or wide beam shear, like a beam shear. Now, now we want to check that depth of 450 with this D is safe for shear. Make a note. One check is punching shear. To check for punching shear, we require capital D and small d. That's all. That's all you require to check for punching shear. But to check for other shear, that is your usual shear, tau E equal to VU by BD. Then we want tau C. Tau C depends on what? Tell me. Tau C, other shear, not punching shear, other shear. Tau C depends on what? Tell me. If you know. Tau C depends on what? Tau C. We want tau E not to be more than tau C. Our usual slab problem. Tau E is the actual shear, not punching. Punching is separate. Punching is special theory, which I never told you so far. Our usual shear. No. PT depends on. Ayo, I told the answer only. Who I am? I am asking tau C depends on. I am telling you answer. See, not cross section. Sorry. What is answer? Tau C depends on PT 100 AST by BD. So, unless you finalize AST and no tension steel, you cannot check for other shear. Yes or no? Write a note here. See, you make a note. Two types of shear are there. One of them is punching shear. Other is usual wide beam shear. wide beam shear, or punching shear is two-way or all round. Wide beam shear is one way, or our usual shear, where you find tau V, tau C, etc. Okay, there. To get tau C, you require PT. But PT means you need 100 AST by BD. Therefore, unless you know AST, you cannot check for other shear. Tell me yes or no. Unless you know AST or unless you finalize reinforcement, you cannot check for other shear. Tell yes or no. Other shear or our usual shear. Tell me yes or no. Unless you finalize AST, you cannot check our usual shear. Punching is separate, I will tell you. Punching separate. Punching shear, you require only D. For punching shear check, you need only D. You are not answering. So unless you finalize AST, that one-way shear or our usual shear, we cannot check. Therefore, what we will do is, the other shear, you will tell, Anna, I will come to you later. It will tell, I am also equally critical. Equally as what? Equally as punching. You tell it, I am making safe in punching now. Oh, you are checking for punching? If you check for punching, if you get safe, it will tell, most probably, I am also going to be safe. Or it will tell you, if not safe, I have some adjustments. It will tell, I will tell you some secret adjustments where you can make me safe. But remember, that adjustment is possible only if it is marginally unsafe. Only if it is marginally unsafe. Marginally unsafe, adjustment possible. See, but not if it is severe unsafe. Like, and if the punching shear check passes, usually this also will pass. Or if it fails, the margin will be very small, some adjustments are there. Therefore, do one thing, this shear we will not bother now. Even if you want, you cannot bother. Why? AST not known. Therefore, now first, as soon as the depth is finalized and D is finalized, tell me next step. As soon as the depth is finalized and D is finalized, immediate next step is check for, tell me, what shear? Tell me, check for what shear? Immediate next step is check for which shear? Immediately next step is check for. You take lot of time to answer. Immediate next step is one-way shear. This much I told, and you are again telling one-way shear. How it is possible? I discussed so much thing. One-way shear or our usual shear, you can check only after finalizing AST. I am telling repeatedly, punching shear you require only D. I told you, if punching passes, that also will pass. Like, if you win UP, you win the nation, that way. If you win the UP means what? Uttar Pradesh. So how many will not be knowing how many seats are there in Uttar Pradesh? Long back it was 85, now it is 80. If you win in UP, I think you can win the nation that way. First you check for which one? Punching shear. Why this much confusion? I am telling so clearly. Or I should not explain this much. Just keep on giving steps. I cannot teach that way. Punching shear. Remember, you remember punching shear, or remember, it is also called as two-way shear. Two-way shear. Or make a personal note, it is all round. You have to consider all round column. Remember, note, you have to consider all round the column. Remember, this punching shear is completely new to you. New to you. New to you. Therefore, I will explain. That shear is not new to you. That I will write note. our usual shear. Someone will tell, usual shear, what nonsense is this? I will tell you are not knowing subject, that's why commenting. Student got confusion. I told the correct principle. I told them easy method of what? Usual shear. First of all, I won't reply to the comment. So first you go for punching shear, complete new for you. Okay, now check for punching shear. I will take a small break and start. No problem. I will not put new class. I will hold the class as it is. Meanwhile, what all you can see, go through briefly if you made it known. Some 5-6 minutes break. No problem. I got reserved to, I have not sent the link actually. I already programmed 2 more links there. If something goes wrong, I can immediately activate that one and send to the group. So, but it is in the unlisted now. I have to make it public and send. Right now it is unlisted. Unlisted means you won't get the notification. So if the class goes in single step, I wrote class extended, then I wrote once again further extended. If any trouble comes, suppose overheating is there or some problem, in such cases I will go for new one. So 5 minutes, let the people who are watching the class later, they will take rest. Okay, just 5-6 minutes. Meanwhile, if you know the punching shear check, you can perform the check. If you know the check, you can perform the check. Not more, maybe 5-6 minutes, that's all. Just 5-6 minutes. Just confirmation. Everything is okay. Voice clear. Microphone is not on. Tell me, voice clear? Everything okay? I'll continue. If everything is okay, I'll continue. This is jumping like anything. No answer. Okay, voice clear? See, no answer. You are delaying a lot to tell the answer because that much lag is not there. Lag is around 10 seconds. Clear. Okay. Start. Now, remember, check for punching shear. I am getting new to you. I will tell all the principles of. Actually, remember now. For E-tab batch, I should tell the procedure with the principle. Others, they should know it, but they can learn simultaneously. And if you remember, because I should take care of my regular RCC class also. For them, I have tell everything. For the regular RCC class, punching shear, I completely explained, and even I got the shear test, then stopped on that day. Remember, correctly, those who are coming for RCC, remember, last class in the RCC, I did punching shear, I explained everything punching, and then I took nearly 2 hours for that one. I told all the principles there, and I got punching shear stress and stopped. Correct? If you remember. Yes or no? Yes. And allowed stress, I have not told much. I will tell here. Okay, start. First, remember, when you check for punching shear, first step, those who want, write a procedure sheet. First, critical section to be considered. See, punching means, remember, it is not your usual shear. Punching shear is like this. See, I will show you. Punching shear. See, this is punching shear. Clear now? Column should not punch through the foundation. See, this is the punching. Clear? The punching idea is clear, first of all. Yes. So, first write, as per IS code, critical section for punching shear. Punching shear is to be considered. Remember, see, your later for wide beam shear, diagonal tension crack will come this way, 45 degrees. Therefore, if this is D, they told consider at D. But no, punching is not that way. It will be steep this way. It will not go at 45 degrees. It will go around 60 degrees. Therefore, IS code told to be considered at not D, D by 2 from face of the column. D by 2 from face of the column. See, our D is 450, our D is 376, right? That is for our question at D, how much? 376 by 2 equal to answer. How much? Fast, give the answer. 3 is, I will make fully clear punching shear. 376 by 2. Answer. I don't have to take calculator for that one. Again, you are not giving answer. See. 376. Calculate not on. 188. Now you are telling the answer. That is at 188 mm. Where? Remember, from face of the column. So, next step. To check for punching shear, remember, if you go, when you design by shape or E-tab and shape, when you right click, what all I am going to write now, everything you can see there. What all I am going to write now, everything you can see there. But that shape, what will do is, it will take this way 1D, this way 1D. Different D's are there. It will take average D. Shape will take average D. We consider least D. That's all. See, first, Write the plan. Write the plan. So that everything is crystal clear. Plan of the footing. See, correctly. Most probably our 450 mm is going to be unsafe in punching. I have a feeling that it is unsafe in punching. The good. Why? We have to redesign. When you have to redesign, what I will do? I will change the depth here, change the small d, change this number, and will take a break. Break means what? Or I will sit there. I won't stand here. I will tell, repeat the calculation. Okay, start. This dimension is not required for you. Okay, if requirement is there, write later. Okay, now. This is the column. See, this is the column. Little out of scale. Okay. This is the column. Now, out of scale. Why? If this is how much? This side is 0.23 meter. Meter I am writing. Meter. This is 0.55 meter. So, this is 2 point something. Actually, it will come bigger. Here, space is not there. See, from here, when you see punching is perpendicular. All round, you take the critical section this way. So that is the punching is going to come this way. See, this way, perpendicular to the plane, punching. This is your, right here, critical section for punching shear. Okay. Distance from here is d by 2. Distance from here also is d by 2. First you find the periphery of the critical section. How to find? Tell me. 0.55 is this one. 0.55 plus d by 2 plus d by 2. Your both the d by 2s are, you want d by 2 in meter now. Why? Because dimension you want meter. 0.188 meter. Not visible. Remember, when you go for punching shear force calculation, pressure is in kilonewton per meter square, you go for meter. When you go for stress calculation, go to millimeter. Therefore, tell this dimension. This is 0.55. This is d by 2, d by 2 here. Tell this answer fast. 18.8. 0.55 plus d by 2 plus d by 2. This much difficulty. 0.926 meter. 0.926 meter. How you got? You got that as 0.55 plus 2 times of that, 2 times of what? 2 times of 0.188. Same way, tell this number 0.23 plus 0.188 plus 0.188. This I will not show the calculation. Why? You are studying engineering. 0.606 meter. Someone will ask me, sir, show the calculation. No, not showing. I will round off. You try yourself only. Okay. And remember, your punching is going to be like this. This is how punching is going. Clear now? This is a plan. See, what you are writing is the plan. See, punching is this way. Clear that one? You should write that way. The punching is going to come perpendicular to the board. Clear or not? Punching is going to come perpendicular to the board. You can't see here. You are tell clear or not? Punching is going to come perpendicular to the board. You are not telling any answer. Clear? Okay. Now, first calculate punching shear force. Punching shear force. See, under normal cases, our shear force is V. When you go to regular shear check later, see later you got one more shear. Which one? Our wide beam shear or one-way shear or usual shear. At that time our symbol is V. To differentiate it from punching, I put always VP. VP means what? VP means shear force, P stands for punching. I am adding the suffix P extra to make that punching is there. VP equal to, see now, if you ask a common person, what he will tell? Tell me. If you ask a common person, what he will tell? Punching shear force equal to, what he will tell? Common person. Which force will punch? Tell the answer. If a common person you ask, what is the punching force, he will tell. Which force is going to punch? Common person without technical knowledge, what he will tell? Common person without technical knowledge, what he will tell? Punching, which is causing punching? No, if you don't answer, I have to stop the class only then. Common person, if you ask, what is the force which will cause the punching, means what he will tell? Common person without having structural knowledge. See, no answer, nothing. Already lag is 10 seconds. It is nearly 1 minute now. Column load, this much time to tell the answer. It is column load. Column load. No, it is not column load. Think a little. See, when you apply a force this way to punch, column load is 850 kilonewton. Now, the plan area, see here, see now, this is the hole, this is the section, see now, this is the punching area, punching. You can see the punching now. Now, column load is 850. See now, the upward pressure on this much area, contact area, will increase the punching or decrease the punching. The upward pressure on this much area, this much plan area, will increase the punching or decrease the punching. Tell the answer. The upward pressure, will it increase the punching or decrease the punching? The upward pressure on that contact area, will it increase the punching effect or decrease the punching effect? Increase. Ayyo, what is this? When you apply a load punching this way, if a pressure comes this way, it will increase. Where this idea comes? How this special idea comes, first of all? How this special ideas comes? Increase. Abba, I am going to collapse now. How to answer? I don't know how. First of all, this much difficulty. Column load is trying to punch this way. Now, in the plan contact area for what? This side, see, this much plan area, upward pressure is acting from soil. Will it increase the punching or decrease the punching? Oh, this is dangerous. Will the upward pressure will increase the punching or decrease the punching? Common sense. Then why you told increase? When you push someone, if he is silent, you can push him. Suppose he slightly protests. Then your pushing force will increase or decrease. If you try to push, see, for example, what I can tell, I have got something here, I will put here, I will try to pushed, but when I try to push, suppose some little gum is here and little rough surface is there, opposite way, will it increase the pushing effect or decrease the pushing effect? This is special idea. How you got idea increase? It will decrease. Therefore, the real punching load is column load minus what? Upward load on what? Plan area within critical section due to upward pressure. Upward pressure. Upward load on plan area within the critical section due to upward pressure. Now, equal to, make a note. You make a small note here. Upward load on plan area within critical section due to upward pressure is, when you know pressure, the total load is always equal to pressure multiplied by area. Area in plan. Okay, at least this is clear. Resultant load equal to pressure into area. This is clear. Pressure is force per unit area. Force per unit area into area will give total load. At least this is clear. This is clear or not? This is clear. Upward load due to pressure equal to pressure into area. At least this is clear. You are not answering. At least when clear means one person sufficient. Why? Maunam sammati lakshanamanta means all are agreeing. If you want, I am telling third time now. Clear? Okay. Therefore, punching shear force VP equal to what? Column load is 850 kilonewton minus the pressure is 154.545. Is it correct? 154.545 pressure, correct? This is directly in kilonewton. This is kilonewton per meter square. 154.545. Is it correct? Is there 154.545 into area? What is area? 0.926. 0.926 into 0.606. This is the plan area or the contact area for pressure. Later for punching resistance, this area. Now tell the answer. Equal to 850 minus how much? No. I want 850 minus how much? Reason is there. I want that minus how much? What is the answer? 850 minus. That number I want. For some reason, I want the second number. No, I want the second number for some reason. For some explanation purpose, I want second number. For explaining you. 86.72 minus 86.72 are equal to how much answer? 850 minus 86.72 is 763.28. Okay. 763.28 kilonewton. Now, make a note. Because of upward pressure, the punching effect got reduced by approximately, tell what percent? Approximately 850 reduced by 86.72 means approximately what percent? Because of the punching, because of the pressure contact area of the pressure contact area, punching force reduces by approximately 10%. So, IS code told this is the force you have to consider. Okay, now one small note. So many design office, what they do is, they do not consider this one. So many design office, they will tell, do one thing, to be on the safer side, you don't consider this one, you check for punching with the directly column load. Tell me, if they do that way, is it on safer side or unsafer side? They will tell. You see that the footing can resist a punching of 850. You can tell him, sir, little shortage is lesser is there, that much is not there. Oh, leave it, I say, no problem. Safer side, he will tell, consider only column load. Safe or unsafe? That is safer side. So many design officers, what they will do is, they will not account this one. But E-tab and safe will account it. Okay, now these are correct. See, when there is a discount is there, you should take the discount. Correct? So now our punching force is 763.28 kilonewton. Now tell me the answer. What is the, therefore, punching shear stress? punching shear stress. Shear stress. Symbol is tau, usually tau v. Remember, usually we tell tau v. Tell yes or no. Usually in the normal shear you tell tau v. Now to identify you put tau vp. Why? This p stands for punching. Later when I go to usual shear, it is simply tau v. Tau vp equal to what? Whatever is your punching force divided by what? Tell me. Tell the answer. Whatever punching force divided by. Remember now, this is the plan area for contact pressure. Pressure contact. Now we want punching. Tell what? Whatever is the punching force divided by. Where is that one? My punching model. What happened to my punching model? Here. Whatever is the contact area, tell me. Divide by what? Resisting area punching. Divide by area resisting punching. Area resisting punching. Area resisting punching. Remember, area resisting punching equal to, anybody can tell the answer correctly. What is the area resisting punching? See, when the punching, see there, I will show once again punching now. See, I will once again show you punching. I got a bigger model here. See, these all you have to remember. No one told me these things to me. I never referred any book. College I never went, first of all. See. This is, tell me, what is the area resisting punching? Fast. Area resisting punching. Anybody can tell correctly? Not answer. Procedure. What is the area resisting punching? It is, see, it is always, see now, this area, see, this area, see, that is perimeter of the critical section into effective depth. So the area resisting punching is equal to perimeter of critical section, not cross section, critical section. Perimeter of critical section into effective depth D. Tell me fully clear or not? First. If it is clear, over. Now nothing to worry. Over. Punching over. If this is clear, punching is over. Then only calculation. Perimeter of critical section into, see, it is this area. All round. Because you took all round punching. Clear or not? First. If clear, I can go to next step. Perimeter of critical section into D. Actually, if it is RCC batch, I have to tell. For them, already told. ETAP batch, formula is sufficient. Clear? Okay. Now write. Equal to punching shear force is 763.28. That is in kilonewton, 10 to the power 3 Newton divided by perimeter of critical section is, now remember, this area we want in millimeter square. Therefore, 926 plus 926 into 2, 926 into 2 plus 606 into 2 is the perimeter. Into D is 376 millimeter into 373. That I should not tell. This perimeter is 926 mm here into 2 plus 606 into 2. Tell me, therefore, what is your shear stress tau Vp in Newton per mm square? This is actual punching stress. Actual developed punching stress, punching shear stress. I am rubbing the full board because then redesign you have to do it. Answer. This much difficulty. 926 into 2 plus 926 into 2 plus 606 into 2 into 376 reciprocal into 763.28 10 to the power 3. How much you told? Point, answer 0.663. Correct or not? 0.663 millimeter power 62. 0.663 Newton per mm power 62. 0.663. Tell me. Correct or not? Fast. Fast, tell me. Clear or not clear? You tell clear, I will go to last step now. What is the allowed stress? If you tell clear, I will go to the last step, that is, how much is the allowed stress? Now I have to compare this with the allowed stress. Because this is the actual stress coming. We want the stress not to exceed the limit. You have to tell clear or not? 0.663. Fast, fast. If this is clear, I will go to next step. That is, for this case, the shear stress due to punching is 0.663. See, nobody gives any answer. Actually, see, this way if you delay, it's difficult to take the class. Lag is only around 10 seconds. This is not 10 seconds. It is more than 1 minute now. This much delay should not be there. When just to type clear, either clear or yes. Once I remove the lag, remember, I will close the class immediately. If the lag is not there, by this time, I would have closed the class. If the lag is not there, by this time, I should have closed the class. Why? Not responding. My class is not simply keep on telling. That way I never take the class. Or there should be some problem now. See, when this much time no reply means I get worries. Is there some problem? See? Is there any problem? I think no problem. Okay. I will just type something now. When I type something, 1 minute, I'll give the volume.
Something.
See, I can hear now my own voice. I will type something now. By that time, if you don't give the answer, I am going to close the class. Simply, I will tell yes. My own comment yes. I typed. See, my comment came yes. Luckily, someone commented clear. I would have surely closed the class now. If you are that much passive, if you don't respond immediately, I cannot take the class. My class is unique. It is not like others. So many people in the beginning, they will tell slowly doing. But once they understand, they will tell this is how actually class should be taken. Not keep on telling something. See? Then why so late? You should answer immediately. 1 minute. Let me remove the lag first. Most probably this week, lag will be removed by app. Then I will close the class and go immediately, telling sorry, I am not continuing. Okay, now, there is a reason for asking. Once again you made the mistake. Sorry, I should quit the class now. I should stop this batch. Once again you made the mistake. 850 kilonewton is working load. This pressure also is for working load. Therefore, this VP also is for working load. Tell what mistake you made. Tell me, what mistake you made? This is, see, in the RCC class, also I got the answer. Then I wanted to tell you suddenly there. But due to some reason, time over. I told, next time I will continue. Next time I was about to shout at you. You made a mistake. The chance never came to me. See, again problem. Tell me, what is the problem now? What blunder once again you made? Tell me. What blunder once again you made? Tell me. What blunder once again you made? Fast, fast. What blunder is again made by you? Someone will tell, you made. I made for you to realize it. Again, no answer. What is the mistake you made? What is the mistake or blunder already done just now? See, I am going to close the class, surely. If this way is the response, I am going to close the class. Working load. I told earlier, if you use pressure of 154.545 kilonewton and column load of 850 kilonewton, then whatever you are getting is for working load. Therefore, remember later when you find bending moment or shear force, at that time, without forgetting, apply gamma f equal to 1.5 and get the factored value. Little today only you made the mistake. Once again made the mistake. Tell me what to do. Tell me now. What shall I do now? After telling so much just earlier, oh, someone will tell, sir, that is for bending moment. Go and see recording. I told, since you are using the working column load and the pressure due to working load, anything you get is for working load. Therefore, limit state method, any calculation you make, you should without forgetting get corresponding factored values. At least tell me. See, I had hit myself only now. Clear or not clear? At least have you realized your mistake? It is not a mistake, it is a blunder. Have you realized the mistake? It is not called a mistake, it is called a serious blunder. Okay. Therefore, as soon as you get VP right, there, remember this is for working load. Therefore, factored value, say VUP equal to how much? 763.28 into 1.5 into 1.5. Now tell the answer. Now tell the answer. Abba, I don't know how to convince. See my age. I am actually very good in, you don't know. I forget things so fast. Sometimes from the room I come here for collecting something. When I reach here, I forget why I came here. I want something. For example, I want calculator. From there I come here. When I come here, I start searching. Why I came? For what I came now? I forget why I came here. Sometimes I want to buy something in a shop. When I go to the shop, the person is known to me. He will usually talk with me about other things. Then he'll ask, "Yen bek sir? Yeno bekagittu." Something. I forget. And you are youngsters. Memory power for you should be more. For me, this is not memory power. It is a concept. Now tell the answer. 1144.92. 1144.92. Therefore, formula is not VP, VUP. Tau is tau only. So, make a mistake here, correct it. 1144.92. Now tell the answer. 0.663 is wrong. Tell the answer. 0.663 is wrong. Now tell the answer. Eto 1.633. Eto answer 1.633. Correct answer. What is the answer you told earlier? What is the answer you told earlier? Tell me. How? Earlier you told 0.6. How it is possible? Earlier you told answer 0.663. 0.663 into 1.5 will give you 0.9945. What is happening first of all? How it is 1.633? I don't know what you are doing. Earlier you told the answer point how much? 633. When you told earlier 0.633, now how it is becoming 1.633? What is happening first of all? What is the problem with you? This, I think I should stop the class. Better, I am going to stop now. Really, I am going to stop the class now. Today's class I am stopping now. Because of this completely reckless way of giving answer. Because of non-involvement, reckless way or irresponsible way of participation. I am very sorry. Reckless way, irresponsible way you are participating. .28. 763 point, again reckless way, 763.28 into 1.5 is 1144.92. How you got first of all that 1188.28? From where you got? I don't know what is happening. Sorry. As soon as the punching is over, I am going to close the class. Next time be responsible. 763.28 is correct. 763.28 is correct. Tell me. 763.28 is correct or wrong? Tell me fast. That 763.28 is correct or not? You tell me the answer. This 763.28 is correct or not? You just comment now. See what I am going to do now. 763.28, is it correct or wrong? Tell the answer. I wrote here 763.28. Is it correct or wrong? That also 1 hour time to answer it. 763.28. For that, I have to wait half an hour to know whether 763.28 is correct or not. I have to wait half an hour for that one. This much lag is not there. This much lag is not there. You are not answering. All are waiting. Let somebody else give the answer. Let me take rest. Or you are busy with Facebook or Instagram or somewhere else. Halfway through listening here. That is not the way to attend my class. I can stop right now. Right now if I stop, next time I will write again. I don't want that one. It will give trouble to me only once again. I cannot tell, see last time. This time only you can't see properly. Correct. If 763.28 is correct, into 1.5 is 1144.92 is correct. 1144.92 correct means what? 1144.92 10 to the power 3 divided by 926 into 2 plus 606 into 2 divided by 376 comes to 0.9938. It comes to 0.9938. Remember, this is the actual shear stress coming. This is correct. 0.9938 is correct or not? Correct. If 0.9938 is correct, then how you gave that 1.633? How you gave that 1.633 earlier? How that 1.633 you gave earlier? I want reason. I want answer for that one. How you told that 1.633? I got first 0.633. 0.633, how it jumped to 1.633 for at least 3 minutes? Nobody responded. Then after I checked it, then you are telling 0.9938. Then who told that 1 point something? 1.633. Rohit, he told 1.633. How it is 1.633? What? You thought earlier came 0.633, therefore put one extra one. How that 1.63 came? Okay, anyway, leave it. See, this is actually disturbing. See, what happens is, already I am taking lot of time for explaining. This, you show me one person who will explain punching shear this much. Show me a person. Then I will answer. People will take not even 10% of time. By this time, footing, everything will be over for them. Axial load over, with the M1, M2 also over. Okay, now remember, the real stress is 0.933 is actual developed punching shear stress is the actual value. Now we want allowed stress. See, I am going to remove now this one. This I am removing. Now, you write a note here. We got what is the real punching shear stress. Now, this much stress is going to come. Tell me, this is good or bad? Tell me, this punching stress coming is good or bad? Punching stress coming is good or bad? Tell me, at least tell that much. Stress coming is good or bad? It should come to your mind. Stresses developed are good or bad? At least tell me the stresses coming, they are good or bad? This much lag is not there. This much lag is not there. I know it. I tested already. Yesterday I tested the lag time. By this time you would have answered 3 times. No, that is because why? Half-hearted. See now what to do. Let me finish this punching now. Punching shear stress is good or bad? It is bad. Now, to get, right here, now we have to get what is the, to get what? To get allowed punching shear stress. Allowed punching shear stress. Allowed punching shear stress. Say, usually for usual shear, allowed stress you call tau C. Yes or no? In RCC up to now, allowed shear stress you call tau V. Allowed stress you call tau C. Tell yes or no? Our not usual shear, actual stress you tell, oh yes, good ante. For somebody, punching stress is good. Like if the bill comes more and more for you, you are very happy, correct? Very good. So you are very happy if high stress comes. Very good. Okay. Now, in usual shear so far, shear stress we call tau V, allowed we call tau C. Tell yes or no? Yes. Here, shear stress we call tau Vp, allowed stress say tau Cp. See, say tau C only, symbol is same. Tau Cp means what? That is allowed stress in punching. Okay, now what to do? Refer IS code. Remember, even for RCC batch also, this is not told. Tell yes or no? Even for RCC batch also, this is not told. Tell me yes or no, those who are in RCC. Even for RCC batch, this is not told. I will tell now. RCC batch also, this is not told. Yes, you are not in RCC batch. Nanda Kumar is commenting. You are not in RCC batch. Yes, okay. Yes. Now remember, allowed stress, IS code told. See, allowed tau C for usual shear depends upon PT. This is not that allowed. This is punching allowed. As per IS code, tau Cp, that is allowed stress equal to Ks into tau C. See IS code, page number, you search later. Where is my IS code? If the IS code is here, I will tell the page number for you. IS code is not here. Somewhere here it was earlier. I don't know today where. No, it is not there. I kept it somewhere. Now not able to get. I misplaced somewhere IS code. Where is it? 1 minute. If I get it, I will tell you page number. Okay, no problem. Page number you search. You can see in the IS code flat slab. In the flat slab chapter they are given. Sufficient? Can you search or not? Can you search yourself? Tell me. I am going to write the IS code provision to get allowed punching stress. You can search IS code and write the page number. Okay. No, this yes is old yes. New yes. I don't have IS code here, but I know the values. I will not write IS code page number. You search IS code and get the page number. Okay? At it good for health. Some practice. It comes under special design requirement, flat slab. You are not answering for that also. Okay, yes, see. Page number you search. But I know IS code. So, time being, remember, this is my IS code. I can see. Hey, Barappa, come. Yes, came. Yellow shear stress tau Cp equal to Ks into tau C. Where they told this tau C is not that tau C. This is a punching tau C. Tau C is 0.25 into root FCK. FCK should be in Newton per mm square. This is dimensionally non-homogeneous. Tau C comes this much Newton per mm square. Dimensionally not homogeneous. So tell the answer. Equal to 0.25 into root of 25. Answer. 0.25 into root 25 will give tau C. It is not allowed stress. Allowed stress is into Ks. I will tell you what is Ks. Answer. Answer. In limit state method. Working test method, it is 0.16 root FCK. Why? Divide by 1.5. That's all. Don't tell page number. Let them search. Don't tell page number. Let them search. 1.25 Newton per mm square. Okay. Tau C over. Now you require Ks. Ks is those who want write. Note. Those who are in the RCC group, write it. Others simply wait for some time. It's a correction factor. See, if the column is square or circular or rectangular with one side not too much more compared to other side, either circular or square or rect. This is only for RCC batch. Other people, if you want knowledge, you write. Otherwise, for 5 minutes now, class is only for RCC batch. Okay. If the column is square or circular or rectangular with one side not too longer side, not too high compared to shorter side, maybe 200 by 400, 300 by 500, 250 by what? 450 or 300 by 600. They told ratio within 2, 400 by 800, 200 by 400, but not 200 by 500. Why? It becomes more. In such cases, tell me, the punching is somewhat uniform or non-uniform. First, the punching is somewhat uniform or non-uniform. Answer. Only people from RCC. Others can keep quiet. This is not for you. Little time I am taking from you because I have not explained for them. Tell me. It will be uniform or not uniform. If it is circular, square or rectangle with one side not beyond double the other side, it will be uniform or non-uniform. First, only people from RCC, others not required. Only those who are in RCC. You tell that way, square or rectangle, square or circular or rectangle of not very deep rectangle, not that way. Will the stress will be uniform or non-uniform? No answer. See, asking a question already 1 minute, more than 1 minute over, no response, nothing. Wrong also will do. No, I have to remove that lag. But remember, lag is not this much. This is called not participating properly. Little laziness. Laziness means I can't take the class. See, each answer I have to wait this much time is class cannot be taken. If I have to wait, some will tell you tell, I am not telling. That is how others will teach. They'll keep on telling things. I don't teach that way. No, I told 3-4 times. If it is circular or square or rectangle with one side not too high compared to other side, is the punching effect is uniform or non-uniform? I told 3-4 times. Why again and again? Will it be uniform or non-uniform? Common sense idea. You think of square and circle, square and circular. Again I can't tell. It will be uniform. Uniform means good or bad. Uniform stress means good or bad. Answer. Uniform means good or bad. Good or bad. Uniform means good or bad. It is good. In that case, this Ks is a reduction factor. It is a reduction factor. Remember, it is a reduction factor. Tell me, in that case, Ks is not required. Ks equal to how much? Tell me. If it is uniform, it's a good case. Reduction factor is not required. Tell Ks equal to. Not required. Ks equal to. Then Ks equal to. Then Ks equal to how much? Reduction factor when reduction is not applicable is. Value of reduction factor when reduction is not applicable is. Answer. This anybody can tell. Value of a reduction factor when reduction is not applicable is 1. Oh, 1. Yes, 1. But if it is a rectangular section, say practically nowadays so many people provide 200 by 750. Then tell me, is the punching is uniform with the moments also there? See, there will be not only load, BM will be there. Therefore, will the punching will be uniform or non-uniform? One side will get high stress, one side low stress. Now, will it be uniform or non-uniform? If it is a long rectangular column, think a little. Non-rectangular column, uniform or non-uniform? .918. Who told 0.918? .918 is correct. Told by Rohit. I did not ask you answer. I know that you are going advance. You should first answer my questions. Do you think I don't know how to find Ks? I also got .918. Don't try to give me idea for me. I am not told how to calculate Ks without me telling how to calculate. How you can calculate means you are going ahead of me. Nobody in the world can go ahead of me, remember. Sorry for being overconfident. I will tell, nobody in the world will be able to go ahead of me. They can just come along with me. They will move, majority will come behind me. Some rare cases when it comes to theoretical knowledge, not practical knowledge. Building practical knowledge, I will agree. I am very weak. If I go to a site, I struggle. I can't make out. They will tell one pipe barta sir. Your pipe yarig beka beda. They will tell something coming. I can't imagine. When it comes to technical point or basic structural knowledge, I will tell with the guarantee. No one will go ahead of me. They can at the most come along with me, side by side. You are trying to go ahead of me. Impossible for you. Impossible. You cannot go ahead of me. It will be non-uniform. Non-uniform means good or bad. Non-uniform is good or bad. I am explaining the meaning of KS for the RCC batch. Remember, others will gain knowledge. Sometimes people will tell, you have got other explanation. I know it, but simplest way to explain I am doing. If you know other, come, we will have argument. We will start argument. Let's see where you end up. It is bad. So in that case, they do not want to allow how much? 1.25. They want to reduce it. See, for safety, they do not want to stress say 1.25. They want to reduce it. Then KS is applicable. What they made is, these things IS code has not told. They simply gave a formula for KS. As per IS code, they simply gave formula for KS. If you observe the formula, it will take care of all the logic told by me. See, they told KS equal to 0.5 plus beta C. Beta C, where beta C is ratio of shorter side to longer side of the column. But they told KS value should not be taken more than, how much, tell me again, as per IS code condition, KS value should not be taken more than, how much? It is a reduction factor. KS value should not be taken more than, how much? KS value should not be taken more than 1. Now, see, tell the answer. If it is square or circle, there is both are equal side. Tell beta C. Ratio of shorter side to longer side. Circle. This diameter to that diameter. Answer. What is beta C? What is beta C? 1. 1 plus 0.5. How much will come? 1 plus 0.5. How much it will come? 1 plus 0.5. How much it will come? 1 plus 0.5. How much it will come? If it is a square section, 1 plus 0.5. Oh, you require half an hour for this also to tell 1 plus 0.5. 1.5. But IS code told you should not take more than 1, so take 1. Okay, now suppose it is a column of 230 millimeter by 400 millimeter. Tell the answer. What is beta C? 230 by 400. Answer. 230 by 400. Suppose the column is 230 by 400. Beta C. How much? Ratio. Beta C ratio. Oh, this is 0.575. If it is 0.575, then your KS will come 0.5 plus 0.575. 1.075 more than 1, therefore take 1. Okay, now suppose it is 230 by 460. Okay, then your beta C will come 0.5. Tell yes or no. Beta C will come 0.5. Yes or no? Fast. Beta, if it is 230 by 460, beta C will come 0.5. Tell me yes or no. Yes. Then your KS will come 1. So, for rectangular column, if the ratio is equal to 2, longer side is, if it is twice the shorter side or within the twice the shorter side, your correction factor will not come. Your KS will come how much? Tell me. For square or circular or rectangular section of longer side, not more than twice the shorter side. Tell me KS value. Tell the KS value. Longer side, not more than twice the shorter side. KS value. I told KS plus 0.5 beta C only I wrote here. I wrote 0.5 plus beta C only. Correct? What is wrong? I wrote 0.5 plus beta C only KS. Why you are wasting time for? As per code, Ks equal to point. That only I wrote. Ks equal to 0.5 plus beta C. Why unnecessary it came now? Why the comment came? For no reason. Okay. Therefore, for square or circular column or rectangular column of longer side, not too much more. That is, not more than twice of shorter. If shorter is 200, longer not more than 400. Then your Ks will come 1, means correction is not there. But if the longer side is too high, I told bad, why non-uniform, then Ks will come. Now fully clear IS code logic. Those who are in the RCC batch, fully clear or not? I am explaining only for RCC batch purpose. Tell me, concept fully clear. Why that correction factor came? If you tell clear means okay for me. RCC batch, other solve formula, that's all. Okay. Now remember, now come to E-tab batch. E-tab batch, this much I need not tell. Why? I am giving you structural knowledge. So for general, remember Ks equal to 0.5 plus beta C. Beta C is the ratio of shorter to longer side, but at any cost, Ks, you should not take more than 1. Find Ks by this formula. If it comes less than 1, take less than 1. If it comes more than 1, cancel, take 1. Therefore, for our case, tell the answer. Beta C equal to shorter side to longer side. How much? 230 divided by 550. Answer. For our column, beta C, 230 by 550. Answer. 230 by 550 is the answer for us. What is beta C for our case? Beta C for our case, our problem. Beta C for our case, 0.4182. It is 0.4182. Therefore, Ks for our case, 0.5 plus 0.4182. Answer. Ks for our case, 0.5 plus 0.4182. Answer. I'll remove all this one now. Or 1 minute. I am removing the sketch only. Why? It is coming safe. Why should I bother? Redesign is not there. I will tell what to do. Answer. 0.9182, which is less than 1. Therefore, take 1 is the maximum limit. Maximum limit. Therefore, take Ks. How much I have taken me? For our question, how much Ks I have to take? Tell me answer. It came less than 1. So what is the Ks value I have to take now? 0.9182. Correct. 0.9182. In case you get more than 1, take 1 over. Therefore, tau Cp, allowed stress, equal to 0.9182 into tau C is, taking 0.9182 is, IS code is almost reducing by 9%. Clear now? They want to reduce the strength by 9%. RCC batch, clear? By applying the reduction factor, they told even though it can resist 1.25, you imagine strength 9% lesser. Clear or not clear? RCC batch, clear or not? They want to reduce the strength by 9% for safety because of the non-uniform effect. Because the column is not square or nearly square, it is wide, therefore they are reducing by 9%. Answer. How much answer? Into 1.25. So tell the value of tau Cp. Tau Cp is the allowed stress. How much is allowed? How much allowed stress? How much allowed stress? 0.9182 into 1.25. No. IS code has not, yes, you calculate, it will come 1.5. So reduction is not there. I told 10 times I told it. If it is square also, IS code told same formula. Your ratio will come 1. When the ratio comes 1, 0.5 plus 1 will come 1.5. Therefore 1, not applicable. General formula they told. They, instead of wasting time on explanation, they decided a common formula which will take care of everything. Which will take care of everything they will take. 1.148. 1.148 Newton per mm square. Therefore, your tau Vp means the actual stress. Remember, actual stress, actual punching stress, actual punching shear stress. Shear stress. Our answer is how much? 0.9938 Newton per mm square is less than your tau Cp. Tau Cp is the allowed stress, allowed punching stress, allowed punching shear stress. That is how much answer? 1.148 Newton per mm square. Therefore, tell me safe or unsafe. Answer. Verdict. Therefore, tell me safe or not. Actual stress is 0.9938. Allowed stress is 1.148. Tell me safe or not. This is a common sense required to tell safe or not. No, I just want safe or not. I wrote everything there. I wrote actual stress. No, that is, you have just give verdict now. Actual stress is only one word, 0.9938. Allowed is 1.148. Safe or not? It is safe. Safe. Over. Now, make a note. Make a note. Remember, safe. Over. Therefore, overall depth of how much? 450 mm provided is okay based on what? Tell me. Overall depth of 450 mm provided is okay based on what? Answer. The overall depth of 450 mm provided is okay based on overall depth of 450 mm provided is okay based on punching. Based on punching. Okay. Now, make a note, special note. If unsafe, what to do? By chance, imagine, now actually I wanted unsafe. If I know it's going to come safe, I would have taken depth of 400 only. I made a mistake. I should have taken a depth of only 400 so that it will come unsafe. Because I will tell you one thing. If the depth is lesser, double weakness. Now remember, make a note. Anyway, because this class is meant for E-tab and safe. In E-tab and safe model, if unsafe, increase thickness and run once again. That's all. So make a note. If unsafe, what to do? If unsafe, what to do means increase thickness. But depth of slab, you need not increase too much because make a note. When you increase the depth of the slab, thickness of slab, it has got multiple benefit. Tell me, it has got multiple benefit. This I told you in RCC batch. When you increase the depth for depression control, multiple benefit. Suppose 150 is unsafe. People think maybe 200 required. No, that much not required. Because increase has got multiple benefit, decrease has got multiple damage. See, I will tell correctly. Once I finish explaining, tell me clear or not. Those who want, right. If you increase the depth, multiple benefit. Benefit number 1, depth of slab is becoming more. By virtue of that one, area resisting punching will be more. Good. Benefit number 2, when you increase the depth, your critical section will move further outward. Critical section will move further outward. When it moves further outward, punching force will become lesser because column load minus higher contact area. Punching load reduces, resistance increases. Therefore, double benefit. Therefore, you need not increase too much by judgment increase. Suppose you got around 30% over stress, you don't increase by 30%, increase by 20%, sufficient. Second point, if the depth is reduced, double trouble. One, when the depth is reduced, what will happen? Then the area resisting punching will become lesser. One drawback. Second drawback, when the depth is reduced, critical section will come closer to the column. When it comes to closer to the column, punching force will increase. Therefore, dangerous. Therefore, if unsafe comes, what you do is increase the depth, not by what the number looks like there, little lesser. Too much is not required. Clear or not? Like your deflection control for slab, like the explanation in RCC batch and ETAP batch, I told change of slab thickness for deflection control. You need not increase too much. Tell me, clear or not? Clear? Those who are coming for ETAP and RCC, others should listen and believe me. You see, again, no answer, nothing. I told you after listening everything, tell clear or not clear. Okay. Now, last note for punching. This class is meant for ETAB and SAFE. I will tell you, in ETAB and SAFE, ETABs and SAFE, actually they will just give a number for you. See, ETAB and SAFE, when you design the column and footing, it will show you a number. A number. Like someone told earlier, the 2019 election, I want a number. Don't tell me other things. A number. I don't want to tell much about it. That is actually very immature. A number will give. I will tell you, anybody can tell me, if it is ETAB and SAFE, if you right click on that one, it will tell you all these details. It will tell you, if you right click in the SAFE, then it will tell you critical section, what is the, it will even tell you periphery area also. It will tell you what is the perimeter, what is the everything it will tell you. But outside, it will give you a number. Tell me. That number is ratio of tau Vp by tau C. Means what? Tau Cp. Actual stress by allowed stress. Tell me. You want that number to be what? Tell me. When you go for ETAB and SAFE, I will not tell once again there. I will tell you at that time. See, when I go to ETAB and SAFE, that is the software part, some people are joining for software now. They told, we want to come to only software. I told, wait for some time. They want to join only for software. They told, structural part we are very thorough. How thorough they will know at that time. I don't want to tell the names, but you will be knowing because when I join them to group, you will know so and so is joined. So there is some addition to the batch. Little later, they told, we want only software part. I told, wait for some time. Right now I am almost finishing the structural part, structural knowledge. I will let you know, then you join. So at that time, they are bound to ask, sir, what is that number, sir? I will tell. You told earlier that you know the concept, but I will tell you that number is actual stress by allowed stress. Then they may ask doubt, how to calculate actual stress, how to get allowed stress. Then why you told you know structural knowledge, you have structural knowledge. That time you told me, I want only software, therefore, sorry, that's all for you. Because you should have come for original class. Basic knowledge you should have covered. You thought you know, then he will comment. At that time I thought that I was knowing, now I realized I am not knowing. That is the usual answer I get from people who initially tell, sir I know, structure sir I know perfectly they know. Okay, tell the answer. What number will come in E tab for this model? First, what number will come in E tab for this model? If you perform this model in E tab, what number will come? Ayo. How much number E tab will show here in this case? Ayo, this much difficulty. If you right click, it will tell you everything. In the E tab, if you right click here, it will give all the story. It will tell, yes, sketch also will come there. It will show you critical section also. Some color change. It will show dark critical section. But nobody wants that way. They want to see only number. Only number required. Tell what number will come in E tab and save software. 0.8657, but it will give only third decimal. It give, I don't remember now. Who remembers it here? Suppose, imagine, it gives only third decimal. What number? Only third decimal it will give. I don't know what decimal it gives. I don't remember. Imagine third decimal. It will round up to third decimal. Tell the number. Suppose, don't tell me, sir, E tab is giving 4 decimal later. 0.86. How it is 0.867? Which is that mathematics? 0.8657 becomes 0.867. How it is possible? What is this mathematics? 0.8657, which computer will give 0.866? Okay, 0.866. At that time, I will tell you, punching shear is safe if this number is what? Tell me. So when you go to software, I will not explain once again. I will tell you, already told you earlier. I already told you, the punching, it comes in a box. The punching number, we are happy if the number comes what? Tell me. We want that number to come either equal to 1 or less than 1. Clear now? Either equal to 1 or less than 1. Suppose that number comes to 0.866, means there is reserve strength of around 13.4%. Tell yes or no. Still reserve strength of 13.4%. Tell yes or no. Still reserve strength is there. Tell me yes or no. Reserve strength of around 13.4%. Yes. Now, suppose that number comes to 1.15. Means what? Safe or unsafe? At that time, if that number, see, those who are joining the software part, they are bound to ask at that time, sir, that is not clear for me. I will tell them, not clear for me also. Or I will tell, these all told in the structural part. But we are absent. You only told you know everything. That time I thought that way. See, then it will happen. Suppose it comes to 1.15. Safe or unsafe? Unsafe. How much over stress? Tell me. How much percentage over stress? You make all this note. How much percentage over stress? If it comes to 1.15, how much is the percentage over stress? What is the percentage over stress? %15% over stress. Then depth to be increased or decreased? Depth to be increased or decreased? Tell me. Your depth, you have to what you do? You have to edit. You click the model, go to edit and change the depth. That's all you have to do. You don't have to do any calculation. Your depth is to be increased or decreased? First. Your depth is to be increased or decreased? Increased. By how much percent? Tell me. By how much percent? by how much percent? Okay, increased by how much percent? Increased by how much percent? Around. Increased by approximately how much percent? Tell some answer. Too much of delay. How much percent? Okay, percentage. Need not increase by 15%. I told you, because if you increase the depth, strength drastically increases, maybe 10% more. Tell the answer. Go to edit page, select this footing slab where 450 is there, say 450 into 1.1. Tell the answer. 450 into 1.1. Tell the answer. Overall depth. Fast. 450 into 1.1. Tell the answer. 450 into 1.1. 10% more. This much time. 450 into 1.1. 495. Round off. Round off. Fast, fast. Round off. Round off. Round off. 500. What you do? In the property page, you can see thickness of slab 450. You overwrite 500 and then tell okay, 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 yes, run. Suddenly you can see number maybe 0.97, 0.96 like that. Safe or unsafe? It may come 0.97 or 0.96. Safe or unsafe? Safe or unsafe? Your number will come 0.97, 0.96 like that. Safe or unsafe? Wasting lot of time. Then it is safe or unsafe. Number may come 0.97, 0.96 like that. This I should first remove the lag. Next week, now safe. By chance number comes to 1.01. Ayo, no problem. 500, no. Edit. 525. Yes, safe. Number comes down. Clear? If you get unsafe, now you know. Tell me, now, what is punching shear force? How the punching shear force is calculated? How resistance comes? How to check the safety? Or how to check for punching shear? And if unsafe, how to redesign? Everything. Perfectly clear or not? No. Tell me. All about punching. Perfectly clear or doubts are there? Regarding punching, clear? Okay. Now, punching is clear. Now, once punching is clear, now other shear you cannot go because, why? Reason. Because before going to other shear, what you are doing? Before going to other, one more shear is there. Shear causing diagonal tension. That is this way splitting. See, the shear, punching is safe now. This shear, before checking that one, we have to finalize what? Tell me. Before checking that one, we have to finalize. Reinforcement, we have to finalize. To finalize reinforcement and to check for other shear, the time required for my, because why? Reinforcement not a big issue. mu equal to 0.87 fy into ast d into 1 minus ast fy bd fck quadratic equation solve. You get ast required. Find the number of bars, provide the number, find actual ast provided. You can put there, you find tau v, tau c, and then compare tau v, tau c. If safe or unsafe, what to do I will tell. The time required is around 1 to 1.5 hours. Actually, approximately 1.5 hours. I think. Around approximately 1.5 hours. See, now it is 8:15 p.m. So, usually class, I told Sunday class, theory part means I won't take up 9:30. Why? Feeling tired, non-stop talking. Around 9:15 like that. So 1 hour time is there. At least I can finish the reinforcement part now, which will take only some 25 minutes, 20 minutes. I can finish the reinforcement part. Yes or no? I can finish the reinforcement part. Yes or no? Fast. At least punching other shear limit. I can finish the reinforcement part. Tell me yes or no? Yes, but I am not finishing. Tell the reason. I am not finishing. I am stopping the class right now. I thought of stopping earlier when you are playing with me, when you are irresponsibly giving answer or not responding. I thought of stopping there, but if I stopped there, next time trouble for me. All I have to explain. So I decided, ಒಂಥರ ಹಠ ಹಲ್ ಕಚ್ಕೊಂಡು with somehow controlling myself, I finished the punching. Now, just to show you my protest for no cooperation, I am going to stop the class right now and continuing next week, not waiting for you any comment from your side. Not for waiting any comment from your side.